Now we will discuss the rank 3 tensor. The rank and this tensor is called epsilon ijk. The number of indices are now 3. This is called Levi-Civita tensor. Levi-Civita tensor. This is after Tullio Levi-Civita. Levi-Civita was from Italy, and the city was Padua, and he was from the city from where I did my PhD. So Tullio Levi-Civita tensor is one of the very important tensor with the help of which we can do the cross product multiplications very easily and very quickly. And now you will see that how powerful this tensor is. Now we will have to keep in mind the few things from the previous lecture. There's the number of indices are 3. It means the number of components will be 3 to the power 3, and the number of components are 27. Now if I write I not with a head but just indices I and j k. So if these indices are in a clockwise order, I, j, k, k, I, then we will have the one combination is the clockwise, and epsilon I, j, k is equal to +1 if we have the cyclic permutation or the clockwise permutation, like I, j, k. They are in this order, like 1, 2, 3, 2, 3, 1. Similarly, 3, 1, 2. Then it will be cyclic, and it will be 0 if any of the two indices are repeated. So any repetition will cause this thing equal to 0. So the repetition is giving 0, and then it will be equal to -1 if the permutation will be acyclic or anti-cyclic, or they are in the reverse order. For example, from I to k, from k to j, and from j to I. In this situation, it will give us -1. So there are 3 components which will give us +1. There are 3 components which will give -1. So total 6 components will give us value, while the 21 components will give us 0. So with this, let me say it further, that cyclic means that it is epsilon 1, 2, 3. This is epsilon 2, 3, 1. This is epsilon 2, 3, 1, and then 3, 1, 2. 3, 1, 2. So it will be equal to +1. And similarly, epsilon 3, 2, 1. Epsilon 3, 2, 1, or epsilon means this is 3, 2, 1. 2, 1, 3. 2, 1, 3, and 1, 3, 2. 1, 3, 2. This will give us -1. And this is the Levi-Civita tensor. And now I will write some relation of the Levi-Civita tensor with the Kronecker delta, which is very important. And this is that if we have two epsilon tensors, like one is epsilon ijk and the other is epsilon and lmn, three indices are not matching with each other, so this is equal. We will write this in a determinant form, in a Kronecker delta form. This is equal to determinant I with L, then I with M, and I with N. Similarly, J with L, J with M, and J with N, and K with L, K with M, and K with N. So this is a determinant, and we will now expand this determinant, and this determinant is equal to, let me write it here. The first, skip this row and column, and we will have delta IL, and these two will be multiplied, delta JM, delta KN minus delta JN, delta KM minus, the next column will be minus and it will be delta IM, and when it is skipped, then delta IL and delta means this is skipped, so we will have delta JL, delta KN, delta JL, delta KN minus delta JN, and delta KL plus the third one, which is delta IN, and this is equal to JLKM, JL and delta KL, JM, KL, JL and KM minus JLKM minus JMKL, JMKL. So this is the expansion of it, and now this thing is equal to, let's multiply the terms. So we are having delta IL, delta JM, delta KN minus delta IL, delta JN and delta KM. Similarly, this one will be multiplied minus delta IM, delta JL, delta KN, and minus minus plus, and we will have delta IM, delta JN, delta KL. So this one, two terms are done here, and then finally we are having plus delta IN, delta JL, delta KM minus delta IN, delta JM and delta KL. So this is the expansion that we have. Now let's say we are using two indices to be the same. Let's say I is equal to L. Now with this, wherever we are having L, we will replace it with I. So let's start with the replacement. So I will not repeat it again because it's a lengthy relation, and this one will become I. Similarly, here is L and this will become I. We have L here and this will become I, and we are having L here and this will become I, L here and this is I, and L here, this is I. So what we got here, we will get this term, the first term, equal to, so what this relation will become epsilon ijk and epsilon imn. Now the two indices are the same as L is equal to I, and this will be equal to this one. When this is delta II, then delta II is from our previous. We know that delta II is equal to 3. So this thing will go to 3 because the summation is on 3, means I runs from 1 up to 3. So we will have this thing equal to 3 here. Similarly here we will have delta II, and this term will also give us 3 here. And when we come here, then this is delta IM and this is delta JI. So I can write this one is delta JI earlier and then delta IM later. So this will just give us the, means we can exchange them. They are numbers, we can exchange them. Similarly here, we are having delta IM and here we are having JI. So I will write this one first and then IM and so on. So let's do them one by one. Here this will be equal to 3 times delta JM delta KN minus 3 times delta JN delta KM and minus, now this is JI, so I am writing this earlier, delta JI and delta IM and delta KN. This one is, this is KI, so I am writing this one earlier, delta KI and then delta IM and delta JN plus this one. This is IN and JI, so let me write JI first and then IN second and delta KM, and the last term is minus, this is delta KI, so I write it first, delta KI and delta IN delta JM. And now further, let me use the identity, and the identity was, as we have seen earlier, that if we are having delta IJ and delta JK, then this will be equal to delta IK. So I will use this identity here, and with this one will turn into, these two will turn into delta JM, these will turn into delta KM, this will turn into JN, delta JN, and this will turn into delta Kn. So I will have this thing equal to 3 delta Jm delta Kn minus 3 delta Jn delta Km and minus delta Jm delta Kn plus delta Km delta Jn plus delta Jn delta Km minus delta Kn delta Jm. Now if we look here, then it doesn't matter Jm is earlier, Kn is later, or Kn is earlier, Jm later, so it doesn't matter. If I look here to Jm and Kn, so this term, then there is Jm and Kn here and Jm Kn here. So these three terms will combine. Now this one is minus and this one is minus, which will make minus 2, and here this is 3. So this will be equal to 2. 3 minus 2 will be equal to 1. So delta Jm delta Kn. And then we are having these three terms. My Jn and Km, Jn Km, Jn Km, and Jn Km, these terms. So they will also means this and this will make 2 and minus 3, so it will be minus delta Jn delta Km. So finally we have reached here that this is epsilon ijk and epsilon imn. Now here we have, when the two indices are the same, like I and I here, so we will skip them, j, k and mn. So it will be j with m and then k with n. This is the way to remember it. J with m, then k with n minus the reverse, j with n and k with m. And this is one of the identity that we have proved, that if two indices will be the same, then we will have the relation equal to this. Similarly, if another two indices are the same, like we have the next two indices, which are the j and m, if they are the same, if j is equal to m, like the next two indices are the same, then we will have here, wherever we will have j, we will write it as m. So this one we will write as m, we will write this one as m. So 2 we will write them as mm here. This implies that epsilon and imk and epsilon imn. Now two indices are the same, so we will have delta mm delta kn minus delta mn delta km, and this will give us the relation that this I can write about this one, that this is delta mm, it means it will give us 3. So we will have here 3 times delta kn n minus, now what about this one? If I write this one, minus means I write this one first, like delta k m and delta m n. So it will make no difference because they are just numbers. We can write this earlier, this later, and upon using this identity, we will have this thing equal to delta, and mm will be skipped, and kn. So our this identity will come out to be that this is equal to 3 times delta kn minus delta kn, and this will imply that delta, this epsilon I m k and epsilon I m n is equal to 2 times delta k n. So it's easy to remember. When two indices are the same, we are having 2 here, and this is k and n here. And when the third index is also the same, like we are having now k equals n, then it will give us, this will imply that epsilon I m and then k and n are the same. So this is k and this is epsilon I m and k, and this is equal to 2 times delta k, and for n I will write k, or we can write n here, and then n here, so it's the same thing. And this will give us, again this will give us 3 here, and the result will be equal to 6. It means that when 3 indices are the same, like we are having epsilon ijk multiplied with epsilon ijk, then it means this thing is equal to 6. 2 Levi-Civita tensors multiplied with the same indices, and this will give us 6. So this is about the Levi-Civita tensor, and now we will solve some examples on this one to learn it more, and you will see the power of Levi-Civita tensor, that how quickly we can do the very lengthy cross products relations on this one.